afternoon, everyone. So what I'd like to talk about is Cytec's offering and how we looked at trying to optimize our power costs, and we did this with PowerAssure and their help. And so taking a quick look at this, what we are is a bootstrapped sales tax software as a service provider. We are in the process of looking at some funding and growing our business rather substantially, and so we put out an RFI to look at what it would take to scale up our services and looking at how we can manage our cost infrastructure in this process. And so part of the questions we actually asked are what it would look like if we were to scale up our current offerings, and what it would look like if we were to completely modernize our infrastructure, both software architecture and hardware architecture. And in that process, in working with PowerAssure, we looked at the impact of changing our architecture from an always-on to an on-demand service offering. And so what we did is we took a look at our current infrastructure and we modeled it way up to this is a cost charts of our most optimistic modeling. But the power map and power utilization is accurate to our current offerings today. And so what we were asked to do by our funding sources is to scale it up to some rather substantial load numbers. And if you look at the power map that we captured here, what we saw from this process is that we had spikes of demand and periods of very, very low demand. But if we go to the next page, or actually not the next page, this is how we did the, why don't we let you do this? I'll talk about this in the next couple of slides.
So the first question that Cytec asked us was looking at the hardware side and what can be done on the hardware side. We did a case study last year with the Silicon Valley Leadership Group about hardware efficiency and the power consumption of hardware together with Underwriter Labs, and we took that forward to this year's case study as well. So we looked to their current servers, we did a reference measurement on that server in terms of power consumption. So you have right now something like 270 watt idle, 340 watt fully loaded, which is a fairly typical number in a 2-year-old system. We also looked to transactions per watt and how much power the whole rack could draw and how that scales up. We then compared it to new hardware, off-the-shelf hardware that's available today, 2 latest Intel Nehalem systems, and you get a significant drop in power consumption and a significant increase in computing capacity. So you see something like a 3.6 times increase for the same floor space, same power circuit setup by just upgrading 2-year-old equipment. We saw that's kind of significant. We went one step further and used some custom-made Dell equipment that was specifically made for another customer, and we compared that as well, and you can see even further savings. 42 servers a rack, fully loaded, and you have something like a 4.7 times increase. So when a lot of people talk about space and density, and they are running out of space, they are running out of capacity, doing hardware upgrades and really measuring the power consumption of the servers is a fairly good first step to understand what's going on, what do you buy the most efficient equipment, and then take that and apply it going forward. So the recommendation we did to Cytec was to go with custom-specific servers, high-efficient servers, look for the most efficient components, and then scale up from that and see how much do you really need and how well can you manage it as the next step. In terms of the application load and setup, the load curve shows relatively good moderate utilization during most of the time, a couple of spikes, a couple of lows. It's a fairly typical number what we see with other companies as well. Gives you an average utilization somewhere around 20–25%, with peaks going to 85–90. The hardware we set up in our office to measure the environment and run it through management was basically 40 servers, 1U servers on a single circuit, with complete measurement of watt, power factor, volt, and whatnot. We did monitoring through Modbus and SNMP for different meters. We had square D meters in there, Raritan power strips, Starline busway to tie it all together so that you have one measurement. And that was how we run all the testing, and then we did dynamic adjustments in terms of turning on and off servers as the load goes up and down to map to the spikes and curves on the load side. And Hal can give you more details on the results.
Actually, I didn't do a bill. All right. Anyhow, so real quickly, if we map the utilization curve that we saw of our service against the power draw, what we're going to see here is that unfortunately the utilization and the power curve are not in sync. What we're getting is a full-time draw because our application was designed in 2006, monolithic, and so it's always running. It's actually it's architected to not allow a lot of sharing in order to isolate customer requests. And so our servers are constantly under load, despite the fact that the actual service requests are coming in a somewhat spiky arrival rate. Let's see if we can get this, there we go. We are getting the build, how about that? So as you can see, the power consumption and the application load just don't map very well. And this actually is indicative of a couple of issues that we had to address. When we looked at re-architecting our application to account for this, to make the service request be an on-demand service request such that we can turn on and off processes, turn on and off servers to manage to the load, what we get is something that looks more along this line, where we were actually turning on servicers and to match the load profile, and now our power load is actually very closely aligned with the actual service load. And the net result for us on this scale out would be a rather substantial savings. All right, so if we look at this in terms of what the net effect of the change here, when we were set up and configured to be always